Okay, so we are continuing to work on systems of equations today. We're going to learn about a different method for solving than we did before. And so we're going to go through and start by just reading the question and looking for any important information that we're going to need to use. So we have a whole backstory here about Jeremy staying with his grandmother while she recovers from having surgery. She's feeling much better and he plans to go home next week, but before he heads home, his grandmother wants him to take her to a flea market that she heard about at her yoga class. So she collects old movies and TV shows, and this flea market was known for having a good selection of them. And so here's where we get into the meat of our information. The flea market is selling the movies for $4 each and the TV shows for $5 each. And she took $150 out of the ATM to spend. Okay? She looks around her apartment and she thinks that she has room for twice as many movies as TV shows, for a total of 48. So how many of each will she buy if she wants to use all of her money and all of her available space? Okay, so all that is information that we need to use. So what we come out with is that we have two conditions that need to be met. Okay, she needs to spend $150 and she needs to buy twice as many movies as TV shows. Those are our two conditions that we're going to meet. Okay, so let's start with our variables. Two things that we're looking for: movies and TV shows. So let's call movies the number of movies, M, and the number of TV shows, let's call it T. Okay, so that's where we're going to start here. So now we need to create some equations. So first off, we know that the total amount of money that we're going to spend is $150. So that means that the money that we spend on the movies plus the money of the TV shows is going to equal $150. We want to spend all of that money, so it has to equal $150. So the movies, the number of the movies is M, and they are $4 each according to our information. So $4 multiplied by the number of movies will tell us the total amount we spend on movies. Then we have the TV shows. Well, TV shows are $5 each, so $5 multiplied by the number of TV shows that she buys will tell us the total amount that she spends on TV shows. Okay? Second equation here. The second equation is that she wants to buy twice as many movies as TV shows. Okay, with a total of 48. She wants to use all of that space. She wants to have a full 48 of them. So there should be 2 times the number of movies plus the number of TV shows, and it should equal a total of 48 movies. Okay, so now we're getting somewhere. Okay, so we've got 2 equations, and these are the 2 equations that we're going to use. So first thing we need to do for solving these, we are going to look at these, and you know what, there's a few things that we could do here, but the method that we're going to use today is we're going to find a magic number. Sometimes it's 2 magic numbers, but in this case we only need 1. A magic number that I can multiply one of these equations by to cancel out or to eliminate one of these variables. Okay, so what I'm going to do is I'm going to multiply this entire equation by -5. Okay, and I'm going to show you what happens. So here's the original, the first one, 4m plus 5t equals 150. And then down here, I'm going to multiply -5 times 2m, it's -10m, -5 times t, that's -5t, and -5 times 48, which is going to give us -240. Okay? Now that I have these two, what I can do is I can add these 2 equations together. So 4m plus -10m leaves me with -6m. 5t plus -5t cancels out, so now I only have one variable involved. And 150 plus -240 is -90. So now I have one variable and I can solve. I divide by -6 and m is equal to 15. So the number of movies is 15. Okay, so now we need to plug that in to our equation and find the number of TV shows. So 2 multiplied by the number of movies, we're going to use that original equation, which is 15, plus t should equal 48. So that's 30, and then we're going to subtract, and we get t is equal to 18. Okay, all right, so let's go ahead and check our answers. So we found that we have movies are 15 and TV shows is 18. Okay, so first let's check to make sure that she spends her full $150. So I'm going to take these two values and I'm going to substitute them back into the original equation. So 4 multiplied by the number of movies, which was 15, plus 5 multiplied by the number of TV shows, which was 18, is equal to $150, hopefully. Well, 4 times 15 is 60, so she spent $60 on movies. 5 times 18 is 90, she spent $90 on TV shows. And that should equal $150, and it does. So we've met the first criteria. Okay, now before I plug this second value, these two values back into the second equation, I want you to think for just a second. Okay, she had to spend a total of 48 altogether, or she wanted to buy a total of 48 altogether, movies and TV shows, but she wanted twice as many movies as TV shows. So the question is, are there twice as many movies as TV shows? Okay, so is 15 twice as many as 18? It's not. So the second condition is not met. Okay, and so what happens here is that sometimes we find that it doesn't matter what we do. We're never going to be able to find an answer that satisfies both conditions. And so basically, Jeremy's grandmother is going to have to come up with a different condition. She's either going to have to come up with a different number of movies and TV shows that she wants, or she wants to spend a different amount of money. But she's not going to be able to meet both conditions. Okay? So unfortunately, this is one of those times that a no solution happens. Even though both numbers fit into the equations, they don't actually meet both conditions. So the answer here is that there is no combination of movies or TV shows that will meet both conditions. Jeremy's grandmother has said. Okay, there's no way to do it. So this is a good example of when sometimes our answers are just not going to work out. So we're going to go ahead and do a couple more examples where we use that same magic number idea, the elimination, and we're going to solve a few more problems here in just a minute.